Hi, Professor Rousseau again. Here we are with video number 2 to help us review for our Chapter 5 test. And these last 2 pages are about the vertex form of a quadratic and application questions. So when we look at the previous videos, those were the standard form of a quadratic where we had to find A, B, and C, and we had to work with our formulas to find different aspects of the quadratic's graph. This time, the vertex form of a quadratic gives me, in the equation itself, the vertex, the hk, or the negative b over 2af of negative b over 2a, where we had to do all that work in the other form. They decide to call the vertex hk. When you look at the equation to the right here, you see that we still have our a, that is our coefficient, okay? That still tells us if the parabola is going up or down, and of course the same rule. If it's positive, it's going upward. If it's negative, it's going downward. But here is the h and the k, okay? This is the vertex point, where h is like the x part, right? And the k is the y. Now notice that the h is the part that's in parentheses, and it has a minus in front of it. We have to be careful with our signs when we look at that. The k has a plus sign in front of it. So that's not as much of a hassle as when I see a negative in front of my h. I really have to think about what my h turns out to be. Is it a positive h or a negative h? Okay. So if I gave you an equation, we won't look at the first one, but if I gave you an equation, f of x equals 2 times x minus 3 plus 5. This a squared, or it's not a quadratic, sorry about that. Okay, so change color here, you could see that the x is right there with the x, right? The 2 is the a. We're kind of matching up the pieces. The minus sign matches up with the minus sign, and therefore the h is equal to 3, not negative 3, because the negative, the subtraction sign, is already included. And this is the k, sorry, and the k is equal to 5. So therefore, the vertex would be 3, 5. Let's look at the one that I gave you on the worksheet. So as we come here, I'm going to write that x minus h squared plus k. So as we begin to match up the pieces, a is equal to 2. We know it's going upward. Okay. Now we have to be careful with our h and our k. Notice that here, remember, the formula has a minus in front of the h. So this says that negative h equals 3. Not h equals 3. Negative h equals 3. That means h is the opposite sign. So h turns out to be a negative 3. That's the thing we have to be careful of. And the k is 6. And now we can answer that multiple choice question. First of all, they asked you, is the parabola going upward for a and b or downward from c and d? We can see right away that the a is positive 2, and therefore it's going upward. Therefore, c and d are not valid choices since they think that the parabola should open downwards. No. Now, most students would pick this answer because they would look up and they would see a 3 and a 6. However, watch that minus that's built in front of that h. Therefore, the h is negative 3 and the k is positive 6. So it's not choice A. The real answer is choice B, where the vertex is negative 3 and the k is 6. So let's go to the next one. Kind of the same kind of questions in just a little different light. But here's our function. Let's put the equation over y equals a times x minus h squared plus k. So once again, let's look at the pieces. We could see that a is equal to negative 0.5. That means if it's negative, it's going downward. Even though they're not asking us to graph it, we want to analyze it by looking at that a. Now, let's get the vertex. Well, I'm going to match up the pieces. X matches up with x. Minus sign matches up with minus sign. So h turns out to be 5. The h in the back matches up with the 5 in the back of that parenthesis. So the h equals 5. The k, be careful, let me do that one in blue. Positive k is equal to negative 11. Okay, so the formula has a plus sign in it. Okay, and the k is going to be equal to negative 11. Right? It's people get mixed up with that. I always like to say, well, remember when we were doing y equal mx plus b in the last chapter, right? And we had an equation y equal 3x plus 4. You'd say, oh, that's really easy. I could tell by looking that the m is equal to 3. I'm matching up the parts. And the b is equal to 4. So the slope would be 3. And the vertical y-intercept would be 4. But if I gave it to you right above this way, y equal 3x minus 2, hopefully you wouldn't tell me the vertical intercept is positive 2. The vertical intercept is negative 2. So likewise, when we come down over here, the same logic applies, that k is negative 11. So when they ask us for the vertex, they're asking us for the h and the k, and that's equal to 5, negative 11. The question is, would this vertex be a maximum or a minimum? So remember, we have to notice that the a is that negative 0.9, and negative means that the parabola is going down. So it shoots downward. And if we're trying to look at a picture of it, okay, if it's going downward, we know that our vertex is a maximum. It's the highest point. Okay. So when our parabola is going downward, our vertex becomes the maximum point. We remember that from the previous standard form. All right. So this is a maximum. Let's circle it in blue. Here's a nice question they like to ask you. It's like about a 0.5 question, 0.5, half a point on the assessment. How many times will this parabola intersect the x-axis? Now, usually, let's just draw a parabola, right? And let's draw one that goes up, just for fun. I'm going to give you 3 cases, and then I'm going to erase this. So look closely. A parabola, let's do it in red, can be down here, and it can cross the horizontal at 2 points. It can also be way up here and have 0 x-intercepts. Isn't that really what they're asking you? How many x-intercepts are there? Here it has 2 x-intercepts. And we could get one very special case where that parabola just does this. It just hits it once, and we have 1 intercept. So they're kind of asking you that question here. In our particular example with that function, how many times is the parabola going to intersect the axis? So now I'm going to draw over here to the left so that we, I guess I can keep it up. I can keep the other stuff up there to the right. I was going to erase it, but look, I'm going to draw a new x, y axis. And the reason why the x is so high is because I got to plot that point. Remember that vertex is supposed to be 5, -11. Let's kind of ballpark that with red. 5, -11 is down here. And we know from the question right above that because the a is negative, that vertex is a max, and the parabola is going to go downward from there. Watch this. Now we can answer our question. How many times does that parabola intersect the x-axis? How many x-intercepts are there? The answer is 0. Because it starts below the x-axis, and it goes even lower because the 5, -11 is the highest it ever gets. So it'll never get up to the x-axis. Okay, next one. What's the equation of the axis of symmetry? Well, you remember from a standard form that the axis of symmetry is that -b over 2a, and also that -b over 2a turns out to be the x-coordinate of the vertex. So the axis of symmetry is, the value of it is the same as the x-coordinate. Let's look at the x-coordinate of what we just had. Let's look at our picture above. So here's our vertex. We can call it HK, or we can call it the -b over 2a, f of -b over 2a, and this number 5 is the axis of symmetry. Therefore, what's the equation of the axis of symmetry? The equation is x equals 5. And just for fun, if you look at the picture above, I'm going to draw that dotted line for the axis of symmetry. And you can see that at that number 5, it does a nice job of splitting the left half of the parabola with the right half of the parabola. Okay, so that page was all about vertex form, where you don't have to calculate the -b over 2a. In fact, you can't. The only thing that sticks out in that equation is the actual a. So remember, up here, right? The only thing we can see is the a. We can't see the b and the c. So we can't calculate the vertex, but we don't have to because they give us the h and the k, which is the vertex. Okay, well, let's go to a couple application questions. Okay, so the last page of the worksheet, we have 2 application questions actually, even though there's 3 questions there. And the application questions for the use in our course really talk about the projectile motion of an object. In other words, if you threw something in the air or an object was propelled, okay, and its usual path is a parabola, which is the graph. So they're going to give you a word problem, and I'm going to give you a couple extra questions that you may not see on this test, but you will see on the final exam. So we have an object that's launched at the top of a 160-foot building with initial velocity of 48 feet. You may say, who cares? Well, look, there's the 48. Okay, so the 48, we do kind of, when they give you the story, actually some of those values are right in the equation itself, and the initial height of the building is 160. You see, that's the C. Isn't that interesting? Okay, so here's the function, here's the formula. The height after t seconds, t for time, can be found using the equation right here. The height is a function of time. H of t equals, there's that negative 16t squared plus 48t plus 160. So before we answer any question, let's list A, negative 16. Let's list B, 48. And C equals 160. Okay, we're going to need that because it's in standard form. It's not in vertex form where I have an H and a K. So I know I need to go back to ensuring I can see what the A, B, and C is. Okay, so the first question is saying, what is H of 3? This question, I'll put a little FE. Not on our test coming up, but on the final exam. What does H of 3 mean? It means that the input time is 3. And therefore, to find out what the value is, that's the question, we need to take the t that's in that equation and replace it with 3. So I'm going to put a 3 in there. Okay. When I do that, I pull my calculator out, and I remember my order of operations that says I have to multiply the exponent first. So I get negative 16 times 9 plus 48 times 3 is 144 plus 160. So when I multiply that together, I get negative 144, positive 144, and 60. So what's the value of that? Well, we can see here that positive and negative 144 zero out. So the final answer turns out to be 160 feet. That's what it stands for. And it asks you that question right below. What's the meaning of your answer? Okay. What does it mean? Okay. It means that after 3 seconds, or at 3 seconds, the height of the object looks nicer on the answer key. The height of the object is 160 feet high. So after 3 seconds, the height of that object that was thrown, whatever it is, a ball, a cannonball off the top of a building, whatever. Okay? That's what that means. So when you see H of 3, and they're asking, what the heck is that? That means, oh, I'm going to put 3 in, and I'm going to calculate the height. After 3 seconds, I'm going to see what the height of that object is. Okay. Now, here's the questions you'll see for our tests coming up. How many seconds does it take the object to reach? Here's the magic words. Its maximum. That's another way of saying, I want to know what the vertex is. Okay. And they're asking us for time. Okay. And we realize that the time, we just plugged in the 3 seconds to do that first question, that the time is the actual input. It's like the x, right? So the time is like the x coordinate of the vertex. And the y-coordinate of that vertex is the actual height itself. Okay. So the y-coordinate is the actual height. So remember, it's a function. Input time, out comes a height. Okay. So they want to know, what's the maximum? Where could that happen? Okay. So we've got to get that x-coordinate of the vertex. We must be sick of it by now. But it's equal to, I'm not going to call it x, I'm going to call it t for time. But it's that negative b over 2a again. And now you know why we did it at the beginning, at the very top of the page in yellow. I'm going to bring that stuff down now, because I'm going to need the b, which is 48, over 2 times the a, which is negative 16. So when I do that calculation, I have negative 48 on top and negative 32 on the bottom. I think I better use my calculator. I know the answer is going to be positive with that double negative stuff. But when I divide it out, it turns out to be 1.5 seconds, 1.5 seconds. And there's the answer to our question. They really wanted to know, what's the negative b over 2a? Now, the second part of the question says, yeah, okay, well, it took 1.5 seconds to reach its maximum height. What is the actual height of that object at 1.5 seconds? How high is it? Well, you know it's got to be higher than the 160 feet, right? Because that's where you threw the ball. So it's going to be going upward. Right? So it's asking you, what is the maximum height? So as I said, that height is like the y-coordinate of the vertex. And we know that when we find the y and we have the x, the only thing we do is that means we have to substitute it into the equation. So here's my equation again. We have negative 16 t squared plus 48 times t plus 160. But what are we plugging in for the time? We're plugging in our 1.5 seconds that we got before. Okay, so we definitely need our calculator. I can't do this one in my head. So I've got to multiply 1.5 times 1.5. Okay. And let's do some colors here. That calculation turns out to be negative 36. Okay. This calculation in blue turns out to be 72. We'll keep him in blue. And of course, we've got our red 160 in the back. So I tried to show you the little pieces. Okay? And in the end, the answer is, if I can find room for it, the answer is 196 feet high. Okay. So that means that after 1.5 seconds, the object went up as high as 196 feet. I'm going to draw a little picture. I'm going to kind of go down to all the way up to the top. Let's kind of visualize it. We're at the top of a building. The building is 160 feet high. Okay. We're at the top there, and we're throwing some object off. Maybe we're throwing a softball. And it's going to hit the ground after gravity takes over. We're finding this point here. How high is it? Okay. That's the vertex. And what they're saying is, how much time is going to elapse from when you threw that ball out of your hand? How much time is there? And that turns out to be 1.5 seconds. And at 1.5 seconds, how high up is that ball from the ground? And the answer is 196 feet high. Okay? So that's the meaning if we can get a picture of what we're looking for. That's the kind of question you'll see on the test. have an extra one here that just makes sure that you're understanding the concept. Okay, we've got a hot dog stand that John owns, and his accountant told him that he can find his profit by using the profit equation. Profit is a function of x, where x is the number of hot dogs he sells. Okay. So the x is the number of hot dogs, the p is the profit, the amount of money he's going to make. All right, the take-home money. After his costs are all done, what's his profit? So how many, here we go, how many hot dogs must John sell to get the maximum? We're talking about the vertex again, just like the previous question. And that vertex is the same old thing, that negative b over 2a, f of negative b over 2a. I kind of cheat sometime and say that means you substitute it in. Okay. So let's lay out what we have here. So we have our profit is equal to negative x squared plus 50x plus 68. So, whoops, there we go. Our a is negative 1, our b is 50, and our c is 68. And all we care about is the x. How many hot dogs? Okay. That's the x right there. That's the number of hot dogs. Let's just calculate negative b over 2a. So we'll call it x for hot dogs equals negative b, that's 50, over 2 times the a, which is negative 1. We've got 50 negative over negative 2. Well, that double negative, you can't have negative hot dogs. It's got to be positive. 25 hot dogs to maximize his profit. So you see the point there, that negative b over 2a is the maximum or the minimum if it was going down. But if you remember our projectile motion question above, we could see that parabola, I'm going to change it to black now. If we look at the parabola where I drew the building up here, we don't really see the whole parabola. Okay. But it would continue there, even though it doesn't make sense to be inside the building. Okay. So we're still looking at that vertex, which is negative b over 2a, f of negative b over 2a. Okay, a couple minutes to finish this last one up. This one is just a practice. Again, find the vertex, determine if it's a maximum or a minimum. This should be a nice, easy question if you're asked it, because we can see, again, the a is equal to negative 1, the b is equal to negative 4, and the c is equal to 2. And they're asking us to find the vertex. So we're back to, again, getting x equals negative b over 2a. We're going to be experts at that formula. Negative b, careful, the b is negative 4 over 2. Whoops, what's going on there? Hold on, my pencil went on me. 2 times the a, which is negative 1. So let's see what we get here. The top number turns out to be positive 4, and the bottom number turns out to be negative 2. Therefore, the x-coordinate is negative 2. So that vertex is negative 2 comma something. Now we know how to get that something. We take the negative 2 and we go back to the original function and we plug that into x and we see what the y is. Here's our x, we need our y next. Now, let's look at that equation and make sure we're good with our substitution. We've got to plug in that x, and I'm going to put that in green. So our x is negative 2, he's going in there, and he's going in behind the negative 4. Now we got to watch ourselves. do not put the negative that's in blue in with the negative that's in green. We need to remember we have to do exponents before anything else. This turns out to be 4. That negative sign is still hanging out there in front of it. This negative 4 here times negative 2 is going to be a plus 8 plus 2. That turns out to be the y ends up being equal to, pull that calculator out, 6. Therefore, our vertex is, to answer the question, 2, 6. The second half said, is it a max or is it a min? Well, you know the answer to that. The A is negative. That means that thing is heading downward, that U. That U is heading down, and that vertex has to be a maximum. Hopefully you see that. Some of that's pretty old stuff now, hopefully from the first video. And there is a good little synopsis of some application questions that you'll have. All right. Good luck studying. Review the video. It's got to help you. All right. Talk to you soon.